Welcome to Fast Math Solutions on Maths with EJD. In this video, we have this interesting problem. Using the recurrence relation, Cn equals summation from k equals 0 to n minus 1, ck Cn minus 1 minus k. We want to derive the closed form expression for the Catalan numbers. The previous video is also something related to Catalan numbers, right? So we do want to like move a step ahead, actually. So we are tasked with deriving the closed form expression for the Catalan number using that recurrence relation, where we know that C of 0 is 1. So generally for Catalan numbers, right, C of 0 is equal to 1 and C of 1 is also equal to 1. Okay, so these are initial conditions for this. Initial conditions. Okay. Um, So we need to understand that the recurrence is a convolution sum where each Cn depends on the previous Catalan numbers. And the goal is to derive a closed form expression for Cn, right? Just like we know already. Okay, so maybe I should just write that. So the recurrence relation Cn equals summation from k equals 0 to n minus 1 of ck Cn minus 1 minus k. Uh, the recurrence relation, that is actually a convolution sum. It's a convolution sum. Convolution sum where each Cn depends on the previous Catalan numbers. On the previous Catalan numbers. Okay. Right. So having done that, right, to derive a closed form, to derive a closed form expression for the Catalan number Cn, okay, using the generating function, which we refer to. I mean, I have it under the generating function playlist, and I've also done an example like in line with this previously. Using the generation function, summation from n equals 0 to infinity of the Catalan number multiplied by xn like that. So using the generating function which actually satisfies, g of x equals 1 plus g of x all squared. That's based on the previous video, right? That's so I want to use this, right? So we solve we solve this equation, as follows. I mean, that equation we just have now, this is g of x equals 1 plus g of x all squared. So we need to solve this. We need to solve for gx, basically. So from what we have now, that's xgs, sorry. That is xgs, g of x squared, xg of x squared. Yeah, that's what it is. Okay. So from this now, we can rearrange all of this to have x g of x squared minus g of x plus 1 equals 0. That's if you rearrange, like move this one here, that's xg of x all squared minus g of x plus 1 equals 0. So if you do all this, right, this is, of course, a quadratic equation in gx. So we can solve using the quadratic formula. So using the quadratic formula, Now I'm skipping most of this because I know this is a general idea. So we can solve for g of x, which is minus 1. That's that's like minus b, right? Plus or minus square root of b squared. So b squared in this case is actually the coefficient of minus g of x. That's minus 1 squared minus 4a. A here is the coefficient of g of x, which is x, and c, which is 1. All of this divided by 2a, and a again is x, like this. So we can see that g of x is equal to 1 plus or minus square root of 1 minus 4x all over 2x, like this. So that is what g of x would give us in this particular situation. So, but then we need to choose the correct sign, right? How do we choose the correct sign here? So we want the generating function. We want the generating function to be well behaved, for small values of x, for small x, and since g of x represents a sequence, of non-negative integers, okay, we select the negative sign. Okay, we select the negative sign. That means that now g of x would be 1 minus square root of 1 minus 4x all over 2x. Okay. So that is what our gx is going to look like. This is our gx now. Okay. Now we need to extract the Catalan numbers from the generating function. So to extract the Catalan number, from the generating function, okay. I mean, this is the generating function. That's what we have obtained so far for this particular expression. So what do we do? We have, okay, let me rewrite that. G of x, right, equals 1 minus square root of 1 minus 4x divided by 2x. So we know this part is something we can easily deal with. So we need to use is a binomial expansion now. So using binomial expansion, for the square root part, or should I say for the square root part, can I say it that way? So we have square root of 1 minus 4x. So can we split that up and get something nice out of that? All right, so this is the same thing as 1 minus 4x raised to the power half, like we know. So we can use the general expression, which says 1 raised to the power half minus 4x raised to the power 0 divided by 0 factorial. So I mean, if we can get like 3 or 4 times, will be good. Plus half now into 1 raised to the power minus half, then minus 4x raised to the power 1 all over 1 factorial. Okay, then plus half into minus half, 1 raised to the power minus 3 over 2 minus 4x raised to the power 2 all over 2 factorial. Okay, then we have again, I guess we can take one more term. We can take one more term. So let that term be plus half into minus half into minus 3 over 2. Okay. Uh, 1 raised to power minus 5 over 2. Then minus 4x raised to power 3 all over 3 factorial. And the terms can continue like that. Okay. So let's try to tidy up. I'm going to be jumping as much as I can. So this will be, of course, everything here, 1 raised per half is 1, minus 4x raised per 0 is 1, 0 factorial is also 1. So all of this side is 1. 1 factorial here is already 1. So we have half, of course, this is 1, half into minus 4x, like that. Then here we have this 2 factorial down here is 2. So we can have it as that's 2 first, then the half that was there, and the other minus half. So this 2 factorial is what is coming up down here as half. 1 raised by minus 3 over 2 is 1. So this is 16x squared here. Then this 3 factorial is 6. So we can have it as or 3 and 2, 3 times 2 down there. So we can have plus 1 over 3 times 2. Okay. Then into half into minus 1 over 2 into minus 3 over 2. Then 1 raised by minus 5 over 2 is 1. Then minus 4x raised by 3 is minus 64x cubed plus all those terms. Then we can tidy up 4 that this is 1 and this is minus 2 in 4 is 8. It's 2. So minus 2x. Then here we have 2, 2, 2. That's 8. 8 in 16. That's 2 again. But then we still have minus. That's uh, minus 2x squared. And when we come down here, 3 cancels 3. And we have 2 times. That's 16. So 16 in 64. That's 16 times 64. That's 4, I believe. Yeah, I think it's 4. Yeah, 4. Yes, that's 4. So we have minus 4x cubed, and then we have all the other terms. So that's the expansion we get from this. Should it really be this 16? I'm trying to imagine that again. Um, yeah. So we have half minus 1 over 2 minus 3 over 2. Yeah. I want to be sure of that. Shouldn't this also be 2? Uh, 64, right? 4 raised to power 3, 4 times 4, 16 times 4, 64. Yeah, I think that is 4. But I have a bit of doubt. I have a bit of doubt. Then all these signs too. This is 1. This is minus 2x. Okay. Yeah, it's all minus all the way. But I'm trying to be sure of the signs. So this is 1 raised per half, 1 half, 1 raised per minus half, then half into minus half, minus 3 over 2, then half, minus 3 over 2, minus 5 over 2. Yeah, so this is 6 down here. Should be 4x raised to power 3. Seriously? I'm trying to imagine that this is 32. So 3 factorial is 6 for sure. And there was 8 there before times 2. Yeah. I'm tempted to think this is what it is. Yeah, I think this is what we have. Yes. Okay. I guess I can settle for this, though I'm still a bit skeptical about this part. Right. I guess from what I've done, I can move on. Okay. Worst case scenario, we can truncate the 4x cube part, we can truncate that part if that's going to be some. So in short, we have that part. So you can simplify. We now have g of x we define. So g of x, which was 1 minus square root of 1 minus 4x all over 2x. Now, I'm still thinking about this, but shouldn't this be 2 because it's already following a pattern? It's a geometric thing with 2x. So if you multiply this by 2x, okay, yeah. I think I'm good. It's okay. Yeah, I'm fine because we have a geometric pattern, and that is multiply by 2x. 2x multiply by another 2x. Ah, no, no, no. I think it's not 2x. It's more like x. And that is why I think this part should be 2x cubed. Let me see again. Um, 1 raised to power half minus 4x raised to power 0. Then half 1 raised to minus half minus 4x raised to power 1. Yes. Then half minus half 1 raised to power minus 3 over 2 minus 4x squared. Yes. Then half minus 3 over 2 1 raised to power that minus 4x raised to power 3. So this is yeah, 4 times 4 16, 16 times 4 64. Well, that's what I see there. Basically, I think it's okay. I think it's okay. Yes, I think it's okay. All right, so that's what I have as far as I know. So now we have g of x to be equal to 1 minus square root of this is 1 minus 2x squared minus 4x cubed, which I'm still a bit skeptical about, but that's fine for now, all over 2x. Then we can tidy that up and we have g of x to be 1 minus 1 plus 2x squared plus 4x cubed, and so on and so forth, okay, divided by 2x, so that we now have this and this will go. So we have, now this is getting interesting. We have 2x to be 2x plus 2x squared plus 4x cubed, and so on and so forth, divided by 2x. So if we do all that division, so 2x over 2x is 1. 2x squared over 2x is x. 4x cubed over 2x is actually 2x squared, and that goes on like that. So in this case now, we have the generating function behaving in this particular format. So we see the pattern that this is the power series expansion of g of x, and the coefficients of x raised to power n are the Catalan numbers. They are the Catalan numbers. The Catalan numbers, Cn. We are looking for a closed form. So are the Catalan numbers which follow. So you can see the numbers follow that Cn. It follows that Cn is equal to 1 over n plus 1, 2n combination n. Now, if you look at that pattern, right? So for instance, if you say take 1, so that's 2 combination 1, which is 1. If you take 1, 2 combination 1, which is 1, and then if you put the 1 here, 2 combination 1. Oh, I think we can only start from 0. If you start from 0, makes no sense. If we start from 2, so 2n combination n. 2 combination 1, that's definitely 1. Then that's like 0, 0. So this is half of that one. That's 1. So we have this whole thing. And this expression now, this expression, so this is the closed form. This now is the closed form expression for the Catalan numbers. Okay, so we come to the end of this long journey. Okay, you want to check that up. If you find something you need to clarify, feel very free to let me know in the comments. So subscribe to this channel and hit the notification bell so you can always get alerted each time a new video is released. Okay. Then comment, let me know how helpful these videos are. And if you want to teach a topic or solve a problem, then like and share so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.